Problem number 20. It's a picture problem. I'm assuming that you have the picture to look at as I work through this problem. Part A, an interval from -6 to 10. That's what's shown there. Where is f not differentiable? So what are the things that we should be thinking about for f to be not differentiable? So if f is not defined, it would not be differentiable there. If f is not continuous, CTS continuous, it would not be differentiable there. If your function is differentiable, that means it must be continuous. So it's not continuous, it can't be differentiable. And then we should also be looking for sharp corners, cusps, etc. Okay, so armed with this knowledge, let's take a look here at what's going on here. Everything seems nice and smooth. Everything seems nice and happy here, except that our function is not continuous at 3. So not differentiable at x is equal to 3. Because it's not continuous at 3, it can't be differentiable. Our function is also not continuous at 5. So if it's not continuous, it can't be differentiable. Finally, let's see here, at x is equal to 7, it has that sharp corner there. So here's our list of answers for part A at x is equal to 3, 5, and 7. Okay, so part B, calculate a reasonable estimate of f prime of 0. So f prime of 0 is going to be the slope of the tangent line right here at x is equal to 0. I'm just going to kind of wing it here. So first off, we can see it's going to be negative. Our answer needs to be negative here. If I'm drawing it like that, it looks like that, if this drawing is to be believed, then all we have to do is give a reasonable estimate here. It looks like that the change in y, or change in x, so it looks like we've gone down 2 units. So change in y is -2, and it looks like we've gone to the right 2 units. And so here is my reasonable estimate for f prime of 0. It's -1. It's certainly going to be a negative number. I believe you if you told me that it was like -0.8 or -1.2. -1 is going to be a good estimate. Okay, for part C, D, and E, we have to figure out there should be, I'll get that fixed here. Where is f prime of x equal to 0? Where is f prime of x negative? Where is f prime of x positive? F prime of x is 0 means that the function has a horizontal tangent line. And the only place that has a horizontal tangent line is at x is equal to -2. Sorry, I missed one. It also has a horizontal tangent line at x equal to 2. At x is equal to 3, x equal to 5, x equal to 7, you might say, oh, it's horizontal tangent line here, horizontal tangent line. No, it's not differentiable. Remember we said it's not differentiable. But then I just realized there's one more spot in which we have to make it clear that horizontal tangent line, everywhere from 3 to 5, the open interval from 3 to 5 is going to have the derivative equal to 0. The function is neither increasing nor decreasing on that interval. Okay, so that is part C. Now for part D and part E. Part C, where is the derivative negative? That means the function is decreasing. Function is decreasing from -2 to 2. So x is negative 2 to 2. It's also decreasing from 5 to 7. If we want to do this a little bit more formally in notation, I guess I should write this. Negative 2, comma 2, union 5 to 7. I can write this answer here as negative 2, comma 2, union the interval from 3 to 5. Note that I'm doing the open interval from 5 to 7 because 5 and 7, we already said the function's not differentiable there. Need to exclude that. Finally, where is the derivative positive? Okay, our function is... I just noticed something I had missed earlier here. What did I miss? I missed a point where there is a vertical tangent line. The function is, the derivative is undefined here. Essentially, the derivative wants to be infinity, but we don't say the derivative is equal to infinity. So I need to add in one more spot here where f is not differentiable. I need to include x is equal to negative 4. Okay, so that doesn't change the other answers here, but now what's going on? So it's increasing from negative 6 to negative 4. The derivative is undefined at negative 4. Then our function, again, increasing from negative 4 to negative 2. Starts to decrease, increasing, the function is increasing again, so positive derivative from 2 to 3. Again, exclude the endpoints there. And then it's increasing again from 7 to 10. So yeah, this is I like this problem. There's a lot going on in this problem. It kind of shows you so many different twists in it, and you can see I kind of missed some things on the first pass there. So this is a good problem type to understand.